Hey everyone, I hope you are doing fine. In this video I am going to talk about a very simple control of a stepper motor. I will show you what I have built so far and what I am planning to do with this stuff in the future. So here you can see a simple frame that I built to test the stepper motor and the Arduino code that I am developing. The stepper motor is a simple NEMA type motor. It is very cheap one, but it does the job pretty well. I need it for demonstration, so I do not need good specification at this moment. The motor is attached to a LED screw by a coupler. The other end of the LED screw is supported by a bearing. The LED screw is not perfectly horizontal, but it's okay for now. There is a block with a nut inside it on the LED screw. This allows to convert the rotating motion into linear motion. The block is attached to two bearings by a wooden stick. It's pretty simple. One of the rails of the bearing is a bit wrong. The diameter is not constant along its length, so the bearing is a bit stiff and it is not moving very easily. The frame itself is a simple 20 by 20 mm aluminum or Bosch profile. I like it because it is very easy to cut and very easy to fit them together by using a few screws and some corner pieces. One can build quite complex structures of this thing and it can withstand pretty high loads. And the motor is driven by a simple combination of an Arduino Uno and an EasyDriver stepper motor driver circuit. I also use a simple power supply with 12 volts, 2 amperes to power the EasyDriver board. So here you can see the Arduino code. From coding point of view, it is very easy to control the stepper motor. First we have to assign two pins. One is to control the steps and the other is to control the direction of the rotation. Once we are done with this, we have to set the direction by setting the pin to high or low. Then we have to make a very simple for loop. Basically one step of the loop is one step of the motor, so by controlling the number of the steps we can control the amount of the rotation of the motor. Here we interrupt the coding a little bit and talk about the stepping mechanism and the LED screws. So first there is a parameter for the stepper motor that tells you what angle the axis of the motor rotates by each step. In this case we have 1.8 degrees. So for example, one full rotation is 200 steps. But in reality these full steps are divided into micro steps. For example, with my setup I only step 1/8 of a full step, so I have to step 1600 steps to do a full revolution. Then we can also play around with the stepping speed. It is simply controlled by the delay between the two step signals. So the less the amount of the delay, the faster the speed of the rotation. And of course, if you are using longer delays, then your motor will rotate slower. Here I used 120 microseconds for a full rotation. Here I used 500 microseconds for a full rotation. Here I used 1000 microseconds, so 1 millisecond for a full rotation. Here I used 2000 microseconds, so 2 milliseconds for a full rotation. Then sometimes you can have some issues with the speed of the motor. If you see that the motor is not moving and or giving high-pitched noises, then maybe there is not enough current. Then you can crank up the current using the potentiometer on the EasyDriver board or whatever board you have. Of course, there is a limit in the current, since this is just a small board, so you cannot expect very high currents. Also, you can reach higher RPM by spinning up the motor, but since I am not planning to use the stepper motor in this way, I am not doing anything with it. So now we can use all the information to see what is the travel distance of the block that is attached to the LED screw. In this case, the LED screw has 8 mm LED, and that will allow the block to travel 8 mm for one full rotation. So for example, if I do 3200 steps, then the block will travel 16 mm. Let's do 10,000 steps back and forth to see the travel distance. So now you basically know everything about how to control the speed and how to control the distance with this kind of setup. It is very straightforward. Oh, and I almost forgot to tell why I am using this thing. So I would like to build a miniature tensile testing machine with some fancy functions. So this is a very good exercise to learn how to control the speed, how to control the distance, and to see how the rotation is converted into translation. Also, it is a good exercise to practice the programming in Arduino, and I hope you liked this video. See you next time.